Welcome to Euclidean Geometry. This is part 1. In this video, we are going to discuss and learn circle geometry. We must know few terminologies of circles. Here is the circle. This yellow line is the circle. And now the center of the circle, a line joining 2 points on the circle and passing through the center is called diameter. The distance from the center to any point on the circle is called radius. Radius is half of the diameter. Tangent, a straight line touching the circle at one point is called tangent. Secant, a straight line intersecting the circle at 2 points. The line segment joining any 2 points on the circle is called chord. The longest chord is the diameter. Then we have segment. Okay, that part is called segment. That's a minor segment. The rest of the circle is the major segment. So these are few terminologies we will be coming across. So keep that in mind. Okay. We move on to a basic theorem. The perpendicular drawn from the center of a circle to a chord bisects the chord. What is the meaning of the theorem? The perpendicular, look at the angle here, it is 90 degree. Okay. Angle is 90 degree, you can see it is already marked. And the line from the center is O. And this OM is perpendicular to the chord. That is what is the theorem saying? That line OM will bisect the chord. The chord is AB. Bisecting, what is the meaning? Dividing into 2 equal parts. So AM, the distance from A to M, must be equal to MB, from M to B. So that is the theorem. Now we have certain formality when we prove the theorem. We mention the given information first. What is given? Circle with center O. OM is perpendicular to AB. Then we have a chord AB required to prove. What are we going to prove? We write that AM equal to MB. Then we write the proof. For the proof of the theorems, usually we use our own constructions. So in this question, join OA and OB, and those constructed lines are marked in dotted lines. Okay, OA and OB are joined. Now in triangle, you have 2 triangles here. What are the triangles? OAM and OBM. That is how we start. What we notice here, we write and then try to prove. OA equal to OB. What is the reason? Radii. You write the reason in the bracket. We know that OA is a radius, OB is also another radius. They are equal because it is the distance from the center to a point on the circle. Number B, angle M1 is equal to angle M2. How much? 90 degree. It's already given. Look at OM. OM is a side of the first triangle. OM is a side of the second triangle, but it's a common side. Okay. So OM equal to OM common. Therefore, the 2 triangles, triangle number 1 equal to triangle number 2. Okay, therefore we write this notation: congruent. OAM, triangle OAM is congruent, meaning equal to triangle OBM. Reason of the congruency. What is the reason? Side, angle, side. SAS. Side, angle, angle. Okay, so that's how we use the idea of congruency, SAS. Now what else we have? Nothing. If the two triangles are equal, the corresponding sides, already we have the sides, must be equal. So obviously these two sides are already equal. Now this AM must be equal to BM or MP. Okay, that is how we conclude. So we write the proof like that. It's a basic theorem. Let's move on to the next information. Converse of theorem. Converse. In the theorem we have to prove that AM equal to MP. Now, if AM equal to MP, we must prove that M1 equal to M2 equal to 90 degrees, or we must prove that OM is perpendicular to the chord, the opposite way. Converse of theorems. We must know that one, because when we apply in the questions, we have to know these theorems. We apply them and write the reasons in the bracket. Okay, so we have the proof again here. What is the proof? AM equal to MB given. Okay, we conclude, we have to prove that M1 equal to M2 equal to 90 degree. Join again OA equal OA and OB in the two triangles. Already we have seen how to prove. We write OA equal to OB, which is therefore A and AM equal to MB. OM is common, therefore triangles are congruent. When the two triangles are congruent, M1 equal to M2, but M1 and M2 is on the straight line. Okay, and that will be 90-90. Okay, that's how we prove. Here is one simple question using the theorem we have just seen. O is the center, OB is 6 centimeter, OC is 10 centimeter, and also OB perpendicular to the chord AC. What is our question? Calculate the length of AC. So we are going to use Pythagoras theorem to find the third side of the right angle triangle in the picture. What is the unknown side? BC. BC is the unknown side. We have the hypotenuse 10 centimeter. Another side is 6, and in the smaller side, another small side is BC. Using the Pythagoras, we calculate that. So in the right angle triangle OBC, BC square is equal to 10 square minus 6 square, because 10 is the hypotenuse, OC is the hypotenuse. So we get, on the calculator, we get 64. Then what is BC? Square root of 64 equal to 8. We get 8. Then you can write 8 there in the paper. Okay, you can write 8. When you answer the question, you write 8. Okay, and then you continue. Now what is our question? Length of AC. If BC is 8, we know that OB is a line from the center and it is perpendicular. Then we have learned the theorem. That line will bisect the chord. Bisecting means dividing equally. So if this is 8, BC is 8, then AB must be also 8. Okay, so that is how we have to answer the questions. Okay, so AC, how much is AC now? 8 times 2, or 8 plus 8 equal to 16 centimeter. Very simple question. Okay, let us look at the next question. Another question of similar nature. You can see the line from the center is perpendicular. Again, another line here. So we are going to use all those informations. OM equal to 5, OC equal to 7, and OC perpendicular to AB. Okay, look at that one. AB is the chord, OC is perpendicular. Then we can apply our knowledge. What is AB? AB is already available. 48 centimeter. Okay, you can see that. 48 centimeter. So now we are going to calculate the radius of the circle. How to calculate the radius? We go to Pythagoras theorem again. OA is a radius, OP is a radius. So we can calculate, use the Pythagoras. This is 48 divided by 2. How much? It's 24. AC is 24. BC is also 24. So we have 24 and 7. So use the Pythagoras. How do you get? We get OA. You can also straight away write the square root of 24 square plus 7 square gives you 25 on the calculator. So OA is 25. What is OA? The length of the radius. Radius is 25 centimeter. Now question B, PQ. How do you calculate PQ? In triangle OMP, cut the other triangle. Okay. We have 25 centimeter now. OP is 25. OM is given already 5. Now calculate PM. Again we use the Pythagoras. We get 24,5 centimeter. Okay. So if PM is 24,5, how much is PQ? Double of that. 2 times 24,5. That is 49 centimeter. Okay. Continue. Sometimes we get similar questions, small questions. Let's continue. Let us look at this beautiful question in the diagram. PQ. PQ. Where is PQ? P to Q is here. PQ is the chord OR. O to R is perpendicular to PQ. The chord is PQ and OR is perpendicular. And then it's also intersecting at T. The radius is 13. OQ is a radius. OR is also another radius. Remember that. Okay. PT is 12. P to T is 12. So what you can do is you write down the numbers, available numbers. Okay. That is the best way. Let us write that. This is 12. This is 13. And OR is also 13. Okay. OR is also 13. Now what is our first question? PQ from P to Q. Simple, because OT is perpendicular. You can see that. Line from the perpendicular line from the center will bisect the chord. So if this is 12, this is also 12. Okay, that is our technique. Now what is PQ? Our first question is PQ. We can easily write PQ is equal to 12 plus 12. Okay, let us look at the answers. Number A, we have TQ and PT 12. Therefore, PQ is 12 plus 12, 24 centimeter. What is the next question? PR. We are going to calculate PR, this side. So this one is 12. But in this triangle, we have no idea about this. From O to R, it is 13. But no idea about this. So we calculate this side. This is 13. This is 12. So use the Pythagoras. Okay. How much is OT? You can use the Pythagoras. 13 square minus 12 square. What is that? We use the calculator quickly. That is square. That is 5. So here is 5. Now OR, we know OR is also a radius 13. So if this is 5, that one is 8 centimeter. So we have the two sides here, 12 and 8. Now here, how much is that one? Use the Pythagoras again. Okay, what is the Pythagoras? Use 12 square, root of 12 square plus 8 square, that is 14,42 centimeter. 14,42 centimeter. So that is the method. So good people, that is the end of part 1 of circle geometry. We will continue. Okay.